All right, welcome to another math class, another math solution. Here, look at this question before us here. The question is 2 to the power of a minus 2 to the power of b equal to 2 or 16, like 2016. What is the value of a and b that will satisfy this equation? I've solved a similar challenge on this channel already. Okay, but how do we solve this? Let's refresh our memory on this. So let's take our solution. But before then, if you've not subscribed, go ahead to subscribe. Links. All right. So yeah, let's take a selection. Okay. The number one thing we have to do here is to draw up some assumptions here that will enable us to solve this challenge here. We're having 2 to the power of a minus 2 to the power of b. On the right hand side is a positive integer, and here the left hand side, this is 2, this is 2. So they have the same base, and here we have a minus sign. So what does that imply, or what does that tell us? It means a must be greater than b, because it is only on that ground that a is bigger than b that will have this to be positive. So long we are having here to be what? A minus, right? Good. So let's establish that. So from here we now have a is greater than b. So if a is greater than b, then we can boldly say that our a is equal to our b plus some set of constants here, k. So if it is true, will k be less than 0 or greater than 0? Again, k will be greater than 0. Again, so we're going to have our k will be greater than 0. Okay, now let's look at this part here now. So let's call this equation star. So if we have this as equation star, we can put b plus k in place of 2 to the power of a. That is the exponent a rather. So if we replace our a with b plus k, what will the original equation become? The original equation will now become our 2 to the power of b plus k. Let's put this in bracket, then minus 2 to the power of b, everything equals to 2, 116. Rather. Okay. Now, according to the law of indices, we can rewrite this expression we have here. Okay? The law we say that if you have your a to the power of m plus n, this is equal to our a to the power of m times a to the power of n. But the law says that when you have the basis to be the same and you have a multiplication sign, your dot here means multiplication. So what you do, you add the exponent. That's what we have here. So what we are having here now is similar to this. So let's rewrite it in this format. Okay. So this now implies that our 2 to the power of b times 2 to the power of k, then minus 2 to the power of b, equal to 2016. Good. Can you see something playing out here? Yeah, what is that? We have 2 to the power of b here, 2 to the power of b here. So let's separate that out and see what this gives us. So we can bring that 2 to the power of b bracket. If we use this to divide this here, we are left with 2 to the power of k, then minus. We use this to divide this, we are left with 1. Close bracket. This is equal to 2106 here. Okay. Now, if you look at what we have on the left-hand side of the equation, you discover that this is even number. Why? Because 2 to the power of any number will give us even. Then here we have 2 to the power of k. This is also an even number. But whenever you subtract 1 from even number, it gives you an odd number. So we are having even number times odd number. So we have to rearrange the right-hand side of the equation to also get an even number multiplied by a number. So from here, let's rewrite this side of the equation. But how do we go about this? It is easy. Here we take our 16, sorry, 2 016, right? So we use 2 to divide this. 2 here will give us 1, 2 here will give us 0, 2 into 1 will give us 0, 2 into 16 will give us 8. We go with 2 again, this will give us 5, 0, 4. We go with 2 again, this will give us 2, 5, 2. We go with 2 again, give us 1, 2, 6. We go with 2 again, this will give us 6 and 3. Okay, so 2 cannot go into this. So how many of the 2 do we have? 1, 2, 3, 4, 5. Right? Good. So we can multiply this out now. 2 times 2 will give us 4, times 2 will give us 8, times 2 will give us 16, times 2 will give us 32. So we can rewrite this to in this format to give us 2 to the power of b into our 2 to the power of k minus 1 close bracket. This is equal to, we have 32 times our 63. So we can now say that here we have even, here we have odd. Okay, here like this we have odd, here we have even, then here we have even number, then here we have odd. So we can go ahead and equate odd to odd and even to even. So let's roll out this. This gives us, so from here, let's equate the even to even here. So we are taking 2 here. So this now implies our 2 to the power of b. This is equal to 30 or 2, right? And 32 can be written as what? As 2 to the power of 5. So writing this in this 2, this is to the power of 5. So this now gives us 2 to the power of b. This is equals to 2 to the power of 5. These numbers are the same. So we can what? Cancel out. So this leaves, we now have, therefore our b is equal to 5. Good. Are we learning something here? Okay, so what do we do next now? How do we now solve for our a? Now, we could solve for our a by equating the odd to this odd here, right? So if we send this to this side, this will give us 64. And when we solve for the value of k, we impute it into this to get our b. But that is a long procedure. Okay, I will show you a shortcut for this. Now we'll solve for the value of b already. We can, from this value, go to our original equation and get the value of a. Easy. So from the original equation, which is 2 to the power of a minus 2 to the power of b equal to 20116. What is our b here? Is 5. So we have here 2 to the power of a minus 2 to the power of 5 equals to 2016. 2 to the power of 5 will give us what? 32, right? So we have 2 to the power of a minus 32 equal to 2016. Wow. We can move this to the side of the equation now to give us 2 to the power of a, then equal to 2016. This is plus our 32. So we have 2 to the power of a. This is equal to 2 plus 6 will give us our 8 here. 3 plus 1 will give us our 4 here. Then here we have 2, 0. Okay. So we now have this to be 2 to the power of a is equal to, we can express this in base 2. We'll go ahead to divide this gradually to see if it can be expressed in base 2. All right, so let's do that and see what this gives us. So we have here this, we have 2, 0, 4, 8. 2 into this will give us 1. 2 into this 0, 2, 4. The 2 again we have 5. 2 here will give us 1, 2. 2 here will give us 2. 2 into 11 will give us 5. The 2 into 12 will give us 6. 2 again we have 1. 2 here we have 2. 2 into 16 will give us 8. 2 can equally go again to give us 6. 2 here we have 4. 2 here we have 3, 2 here we have 2, 2 here we have 1, 2 here we have 6, 2 here we have 8, 2 here we have 4, 2 here we have 2, 2 here we have 1. So this number can be expressed in base 2. So how many of it do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this can be written as 2 to the power of 11. So since the bases are the same, this leaves. So when I have therefore, our A is equal to 11. So we'll be able to solve for our A to be 11 and our B, look at it, 5. And if you remember, we said initially that A must be greater than B for this equation to hold water. And so we have our A is equal to 11, B is equal to. And if you put these two values into the original equation, then you discover that they will give us the right answer, which is 2016. I've done that already, and it satisfies the original equation. So this brings us to the end of this class. If you learned something from this video tutorial, do not hesitate to just click that thumbs up button and also leave a comment in the comment section. You like what is going on here, then recommend our videos to other people. All right. Thanks for being there for Online Maths TV. Jakes loves you. Those behind the camera, they love you also. Keep watching Online Maths TV, and until we meet you again in our next video, do not stop to win. Keep winning. Bye till we see you.